example 5 on page 583, solve negative 5x squared plus 2 equals 0. Now, I'm not going to write out get the exact solution and approximate the solutions to 3 decimal places, because on the test, on the quiz or final exams, I only ask you to provide me with the exact solution, so you don't need to find the decimal places. Okay, so when we say solve, it means you give the exact answer. So to solve this equation, first of all, you see that this equation has second power. It means this is a quadratic equation, and the standard form for a quadratic equation is ax squared plus bx plus 2 equals 0. What we got is the x squared term, which is here. We don't have the b of x term that has x to the first power. We do have the constant c here. So you see what we got is this first term and the last term here. The reason we don't have this term because b is equal to 0, which is fine. It's still a quadratic equation. This is the standard form for a quadratic equation. It does not have to be complete like this, but the minimum requirement is that you must have the second power, okay, to be a quadratic equation. So to solve this, if you check the note or the books on page 582, the principle of square roots that say x squared equal to d, okay, the solutions are negative, so positive d, square root of d, and negative square root of d, okay? And then when d positive, this d right here positive, they say the solution are two real number. The solutions are two real number, okay? When d equal to 0, this d right here equal to 0, that means the only solution is 0. The only solution is 0. Again, you can find this in the books or my lecture note. And the last case is when d less than 0, this d right here less than 0, they say the solutions are two imaginary number, are two imaginary imaginary number mean the number have I in there. And we learned in the last section about complex number, imaginary number I. Alright, we're going to solve this equation. Just notice that this equation has this form where there's no term with the x. Okay? So you're going to use this, which is called the principle of square roots. Solution. So we start with the given equation, and we're going to obtain this form so that we can use this rule here. So we have this. I'm going to only have the x squared term on the left. Everything else go to the right. Okay. So to solve for x squared, I will subtract 2 on both sides. Negative 5x squared, this is 0, equal to 0 minus 2 is negative 2. And to get x squared, like this form right here, I would divide both sides by negative 5. So negative 5 divided by negative 5 is 1. 1 times x squared is x squared. Negative divided by negative positive. 2 divided by 5 is 2 divided by 5. Okay? So we get this. I hope you see that what I got here, it looks similar to this. D is some constant. Now, we have the rule here that say if D is positive, the solutions are two real numbers. D, in this case, 2 over 5. That means it's positive, right? Because D right here is positive. So that means there will be two real number solutions So, and the solutions, you can see it here. Let's say square root of d and negative square root of these are solutions to this equation. So to solve for this, you will take x equal to, let's see, plus or minus square root of 2 over 5. I hope you see that I take the square root both sides of this equation, okay? And then this x is equal either positive or negative, because I don't know if this x is positive or not, okay? Because I'm doing the square root on both sides, okay? I'm taking square root on both sides, okay? So as you see, I'm taking square root on both sides. Because this is even root, k equal to 2 is even. I don't know if this x is positive or not. So when I simplify this square root, and this, I will have plus or minus, because x can be positive, x can be negative. I don't know which one, so I put both. 2 over 5. Okay? So let's see how in your books they say when, so you can use this, or in your book they'll show you that instead of writing this, you can say x equal to square root of 2 over 5, or x equal to negative square root of 2 over 5. Do you see that the solutions are square root of d, square root of d is here, and negative square root of d. So what we got here, the solutions are x equal to square root of d. What is d? This one, right? Or x equal to negative square root of d. What is d? D is 2 over 5. So you can write this form, or you can write this form. It's up to you. Okay? And we're not done yet. Let me write this out. Actually, let me make space. So we have two solutions. Again, you can write this one, this line, or you can write this line. These two lines are equivalent. Okay? Alright, so we have the first one is x equal to square root of 2 over 5. The other one is x equal to negative square root of 2 over 5. So we will, for this case, we'll simplify the square root. We'll take the denominator outside square root. Now, phi is prime. You cannot take the phi out. So we need to multiply by phi inside the radical. I mean, we need to multiply by 1 inside the radical. And this 1, phi divided by phi is 1. Guarantee it will simplify the denominator, because phi times phi is phi squared. And phi squared, when you take the square root, you can take the phi out of the square root. That's the reason why I multiply by phi, which is exactly identical to the denominator. And on this side, I will do the same thing. X equal to negative square root of 2 over 5. My goal is to bring the denominator outside of the radical. To do that, I need to multiply by 1. And this one is 5 over 5. This phi matches with the denominator, okay? Identical to denominator. That's what I want. That's why I multiply by 5. Similar to denominator. Simplify, I get square root of 2 times phi is 10 divided by phi squared. Or x equal to negative square root of 2 times phi is 10 divided by phi squared. The goal is to bring the denominator outside of the radical. For this, you can rewrite this as square root of 10 and square root of phi squared. We learned this in the last sections, how to split a radical. This is x equal to negative square root of 10 divided by square root of phi squared. Okay? Now phi squared, the exponent matched with the index k equal to. That means you can simplify the denominator to phi. The top still stay the same, square root of 10, or x equal to negative. This phi has exponent 2 matched with k equal 2 because it's square root, k equal 2. That means you can simplify this radical to 5, and the top is just radical 10. So we have two solutions now. The first one is square root of 10 divided by 5, or x equal to negative square root of 10 divided by 5. So let's check solutions. Before I go on, I hope you see this. This d2x, okay, d2x right here. I mean, we don't need to write all the x, because all into this x right here. So d2x equal to square root of 10, and this one's square root of 10, but you multiply by negative. So another way of writing this solution, you can say x equal to positive or negative square root of 10 divided by 5. Do you see that they are identical? Square root of 10 divided by 5. The only thing different is plus or minus. So you can put both solutions in this form. Okay? And let's check. The equation we have is negative 5x squared plus 2 equal to 0. Because this is x squared, anything squared is positive. So that means we can test this solution at the same time. You don't have to check each solution individually, okay? Because this is square, any value plus or minus, when you square it, it's still positive. And because these two x have the same form to the opposite side, that means you can test right away. Test both of these solutions at the same time and plug into the x squared. So negative 5, what is x squared? X squared plus or minus square root of 10 divided by 5 squared plus 2. And you don't know if the left side equals the right hand side, you put a question mark. To simplify, negative 5 plus minus square is still positive, okay? And then square root of 10, you square it becomes 10. 5 squared becomes 25 plus 2, you don't know, equal to 0. 5 and 25 you can divide. So 5 and 25, this becomes negative 1, this becomes 5. So negative 1 times 10. So negative 1 times 10, okay? 5 divided by 25 is negative 1 times 10 divided by 5. So actually simplify to negative 2. Okay? So all these multiply, you get negative 2 plus 2 equals 0 not. And it turns out it is, because negative 2 plus 2, and you try to test, negative 2 plus 2 is 0, and 0 equal to 0. So this is true. So that means these two solutions, x equal plus or minus square root of 10 divided by 5, are solutions to this equation. Now, I want to emphasize this. For this example, you only need to check one time, because these two solutions are the same to the opposite side. They are the same opposite side. And when you bring these two, you can test at once, because both raised to the second power. When you raise to the second power or even power, everything that positive and negative become positive. And because these two have the same values, this opposite side, you can test, you can substitute these two solutions at the same time inside x squared or any variable with even power, because guarantee you will get the same value. That's why I test both of these at the same time and I square it. Then doesn't matter plus or minus, when I square it, I still get the same value, which is 10 divided by 25. And the solutions are, let me clear this out before I erase everything. Make sure you see this. And then let me write a conclusion. So we have I just erased what I'm supposed to keep, so let me write it out quickly again, the solution. So we multiply both sides by 5. I should have said the top one, but I'll resolving this here. Simplify, we get 5, 25, actually 5 squared and then 10 or equal to negative phi squared and 10. Simplify, we get phi here. You don't have to copy this because I already showed you. I just accidentally erased and I wanted to show you what is the final answer by n squared root of 10. So these are the two solutions. So you say x equal to positive negative of square root of 10 over 5 are solutions to the equation negative phi x squared plus 2 equal to 0. And I show you that when I test d2 and substituting d2 into this equation and both raised to the second power and simplify, and I got 0 equals 0, which is true. So that means these two solutions are the solution of this equation, and this is how you solve it. This is the answer.